Hi, I'm Pruitt Chamness. I lead cloud sales and strategy for WEKA.
Hello, I'm Efraim Grynberg, and I lead the global pre-sales team in WEKA.
We're here to talk about customers and how customers are using WEKA to solve real-world problems in the cloud. And one thing that you'll notice is we support customer use cases across a wide variety of industry verticals, and also for customers in different stages of the cloud adoption, whether they're trying to migrate from on-prem to the cloud or they're fully cloud native and looking to get the most out of cloud infrastructure. So we're going to start with Infor. Infor may be a recognizable name for some, but they are a huge multinational, multi-billion-dollar company, and they're part of the Coke Industries portfolio of companies. We first started talking to Infor about their Cloverleaf software. This is a healthcare message processing software. So when hospitals and doctors are sending data to labs and radiology and pharmacies, the Cloverleaf software is the software that does that message processing and translation. Needless to say, because of the sensitivity of this data and the importance relative to patients, downtime and performance is extremely important. So Infor started talking to us, not necessarily around performance, but around reliability. They had experienced an issue with their native architecture related to an AZ failure that left them experiencing downtime and unable to deliver messages. And so they came to WEKA because of our multi-AZ architecture with the idea that they wanted to be able to drive some resiliency into their architecture. I'll let Efraim talk about that.
Okay, so yes, the Cloverleaf team was in a mission of moving all their application to the cloud. That's what Infor does. They want cloud first, and it's an application that is there for a few years already, and it's a healthcare application. Like a clinic might send messages to doctors with information about patients. It has reliability, performance. Those are very, very important metrics for them. And they needed to move all this application while they still are serving their customers, and they give same or better experience, of course. So first of all, there were some metrics that they modernized the application, containerizing, and they wanted to use as many AWS native applications they could do. So EKS integration was very important for them. We have our CSI plugin, you can do Kubernetes, but they wanted to have EKS integration, we gave them. They want an easy way to migrate to the cloud, and they have a performance to hit, okay? They wanted to be able to get what they call 15 million messages per second, minute, hour. And they couldn't get it. They were at a point when they talked to us that they were stuck. The maximum they could do was 6 million messages, okay, healthcare messages. And they were trying to use different services, native to AWS, no native to the AWS, and that was stuck. They were thinking about rewriting the entire application, what would take about 2 years to 3 years based on their estimations. The other important thing was high availability, reliability. They needed a solution that can live across multi-availability zones. So if an availability zone goes down, the application still runs and deliver the performance they need. When they try WEKA, immediately the numbers just sold the product for them. Instead of getting 6 million messages, they went to 69 million messages, okay? Without any tuning on the application, without any tuning on the file system. Copy data to WEKA, that's what they got. So the performance problem was eliminated immediately. By the way, another important thing is that with WEKA, they have almost 0 messages on the queue all the time. And from a reliability perspective, it's very important because if there is an interruption of the application for any reason, it means that there are no messages that are lost in the queue. And how we provide to them availability, we use we stretch our cluster to multiple availability zones. If you remember, Shimon and talk about how we distribute and protect data. We have, in this diagram, this will be the i3 instances that we use to install our software. They have NVMe, and of course, everything also, we have a tier to S3, okay, to object store. What happened? Like every 4K blocks that we write, or every blocks that we write, we are writing 4 blocks, 4 blocks, 4 blocks, and so on. Okay, actually 4 blocks, 4 blocks, sorry, 4 blocks, 4 blocks, 4 blocks, and we protect twice. We have two parasites. Actually, what we are doing is that we can have one instance or a group of instances. We say that the minimum of a cluster for us is 6 nodes, right? That means that each one of the nodes is a failure domain, okay? A node can fail, cluster still continue working, but what we can do is actually have a group of instances and put them all in a failure domain, okay? So we can have actually double the instance or triple the instance, but the same type of failure domains. Now, most of the regions in AWS, they have 3 regions, right? Most of the regions in AWS, they have 3 availability zones. What we are doing here is that we are putting 2 failure domains in each availability zone. Now, let's say that we have a failure in one of the nodes. In any availability zone, clusters still continue running. Okay, we are in an N+2 type of protection. Another node that fails in another availability zone, everything is still working. Now, what happens if we have a full availability zone that fails, that goes down? Okay, which is this click. I still have 4 nodes running or 4 failure domains running. Actually, in this diagram, each failure domain has 2 nodes, okay, two i3 instances. I still have a cluster that is running. And all the application nodes that are distributed, or the application servers that are distributed in all the availability zones, they still can work. Yeah. So this is a way, yes, go ahead.
Quick question. I mean, if, for example, in this situation, does that mean that your environment now is at risk? Or do you now spin up more instances just to cover that risk in the same availability?
So we can spin up more instances immediately. Autoscaling will do that for you. But yeah, you could say that the environment is at risk, but from the other side, the environment is working, which in many, many cases, if you have an availability zone that is down, all the application is down.
No, now it's working. What I mean is that, you know, for example, if you lose another one of those,
you are at risk. But there are other layers of protection. One of the things that you can do is to take snapshots, right, and push them to an S3 bucket. You have a full coherent image of the entire application. So maybe you don't have a high availability in terms that if you lose another node, the application will be down, but you still can recover from it without losing data. So yes, it's not an ideal situation, but it's not an ideal situation that an availability zone goes down and you still have protection, which is one of the things. Now you have zero messages in your queue. You don't have that loss of data, okay? So this is one of the protections. Again, for them was from not being able to port their application to the cloud in the time that they put to themselves, to being able to do that. Protection across multi availability zones. Performance, it's just ridiculously higher. We don't talk about that even, but isn't. And one of the things that I didn't mention here is EKS integration, and another things that they are using is multi-protocol. Okay, we talked about WEKA is not a managed server, and even though we can manage it for you if you want from a commercial perspective, but a lot of our customers feel that it's very, very simple for all the automation, because actually WEKA allows you to use one solution for all your protocols that you need, instead of using very different services that you have and moving data as you need. We do all that orchestration for you. manage all your data for you. Another question? No? Okay.
So next we're going to talk about 23andMe. If you're not familiar with 23andMe, I'll invite you to crawl out from under the rock that you've been living under. So 23andMe is a DNA company. They take an at-home test and are able to deliver insights around health as well as genealogy. And 23andMe committed to move to AWS at a corporate level, and then kind of had to back into how to actually make it happen. And there were two considerations that they were making. They were extremely cost sensitive. They needed to be able to move their data pipeline to AWS without having huge cost overruns. The second consideration that they needed to make was they wanted to move without impacting the way that researchers access data. And so the tagline that I love here, and it came from their CTO, is they were able to move petabytes of data, millions of lines of custom code, and dozens of pipelines without impacting the way that researchers access data. And on top of that, they were able to do it in a cost-effective manner, leveraging our cloud capabilities from a tiering perspective, snap to object, and being able to independently scale performance and capacity. I'll let Efraim jump into the architecture.
So there was a question before in one of the previous presenters, I think it was to Shimon, is whether there are customers that are using the tiering to object store and how they are using. So to get a little bit of proportions, 23andMe is using 1 petabyte of flash, okay, on i3 instances. They have a fairly large cluster, and they are using 30 petabytes of object store. So their data set is 30 petabytes, about 30 petabytes on the cloud. Most of it is on S3. Now you can say 1 petabyte of flash is expensive, but if you think about 30 petabytes, where most of it is on S3, so then the cost makes a lot of sense. And as Pruitt says, cost for them was extremely important. Now, another important thing that 23andMe did is they did test to production. Okay, they identify WEKA, they started test WEKA, they decided that WEKA is the right solution, okay? And they move WEKA to production after migrating 30 petabytes of data and still providing their developers, researchers to work it in. In how much time that would take in on-prem? Year probably or more? 3 months from starting to engagement to production. So deploying WEKA multi-protocol, again, they wanted a single solution that can actually, all their applications can access the same data at the same time doing multi-protocol. It was S3, SMB, and POSIX, or they wanted NFS, but we demonstrated that POSIX can work better for them, right? So a lot of cost-saving, other cost-saving features that they are using, auto-scaling. Actually, another question was, do customers use auto-scaling? And the answer is yes. And we not only developed auto-scaling because we had this great idea, actually it was one of the big requests from 23andMe. Okay, imagine Christmas time, you decide to give to your family, all your family, 23andMe kits to test them.
I'm a perfect example of this. My whole family got 23andMe kits for Christmas this year.
They have a massive burst on need for performance and capacity. Okay, so this is the first a perfect example why auto-scaling is a good option. They scale the cluster automatically during that time, 2 weeks, 3 weeks, one week, whatever they need. After that, they can shrink the cluster, and they don't have to pay for a larger cluster that they don't need all the time, only for that period. So very cost optimizing that example. Okay, and we have a few more examples.
So the next example that we're going to talk about is Praymaker Studio. So M&E is one of those historical markets where it was kind of a last bastion for on-prem. Having worked in the cloud for a long time, M&E, particularly VisualFX in production, was one of those non-starter type workloads, primarily because of the performance required to run applications like Flame and these very high, data intensive with no frame loss, 4K videos, things like that. And so sometimes in an industry, it requires an innovator to come along and shake things up. And that's exactly what Praymaker did. Praymaker set out from the start to be a visual FX studio in the cloud. And they would say that their peers kind of laughed at them at the start. They looked at every storage offering out there and ultimately arrived at WEKA for a couple of reasons. One is the performance that they were able to achieve for their data intensive applications. And then two is data portability. By leveraging that snapshot to object, they could move workloads around so that they could give artists access to data wherever they were in the world. And in a COVID environment, this is increasingly important because you've got work from home and you've got artists accessing data from different places. I'll let Efraim talk about the architecture.
Yes, so the architecture in Praymaker, actually Praymaker is not a massive customer in terms of, they are not big, they are doing incredible stuff. They are a relatively young company that born in the cloud, so they say, okay, we're identifying this problem that is doing VFX and studios and everything on the cloud, and we allow them. And they are using every feature that WEKA can provide to manage their environment and cost optimization of cost on AWS, and also taking advantage. So it's a, won't have time to talk in 1 minute that we have left and about all the things that Praymaker are using. Actually, we have videos with them, but auto scaling is one of them. The ability to take a snapshot, okay, move a project, they work on project base, that they have 7 years of shelf life cycle. That's the industry. They can take a snapshot of the entire project while they are not working, then throw it to an S3 bucket as a snapshot. They are not paying to us capacity nor performance anything during that time, and because it's not part of the cluster, they can push it to S3 Glacier to pay less to S3. And if they need it during those 7 years, they just can recover the snapshot, create a file system out of that snapshot, and get all that data back again. That's a little bit of what Praymaker is doing. They are doing much more.
Just regarding the on-premise solution, do you have any kind of hardware compatibility lists, or would you view it as hardware agnostic, given that it's probably JBOD level access?
No, actually, we are very hardware agnostic. We have reference architectures with all the main vendors, and we just need servers, memory, NICs, and NVMEs. Very simple. Every hardware vendor will have it.
And any networking issues or controller issues? Or...
We have some recommendations, and we have requirements, okay, that we have. Of course, we work with NVMEs. We like 100 gigabit networks on-prem, things like that. But there is nothing that you cannot check from many servers from many vendors all the time. Okay. It's pretty standard.
Thank you.
You said you don't have any kind of software as a service offering at the moment. So the customer needs to set up his own environment, as we saw. But how do you license it? How does WEKA get licensed?
So it's a customer deployed solution. So it runs inside the customer VPC. We license based on capacity, flash capacity and object capacity. And then from a managed service, we have a professional services organization that can deliver whatever type of managed service offering a customer could want. But again, it's highly customizable to the customer. You know, the core way that we deploy is really a self-service model, just like AWS, where the customer buys the software. We give them best practices, deploy it, and then they deploy it and scale it as they need.
But we are an enterprise software, right? We are an enterprise company. We have customer success curve for customers. We are there all the time. That's part of the pricing. You don't pay for support apart.